Alright, so let's go for it here. So with these rational expressions, i.e. fractions, we are going to have to just learn how to multiply and divide them. So let's go back to pre-algebra, because these are just same stuff as pre-algebra, just with x's and y's and other variables in them. That's all. So just recall from pre-algebra, 3/4 times 10/25ths, sorry. We can do it sort of two different ways here. You can multiply straight across first, and then see what we can reduce, which is what we did in 6.1. Good. A little bit shorter process though, because notice you got an 84 on your hands. Some big numbers to reduce. Don't want to do that. So instead of multiplying first and then, in a sense, technically dividing out or factoring out the process, we're going to factor out first and then multiply. So we have to break these down into its prime numbers. 3 is already prime, so it doesn't break down. 4 is really 2 times 2. 10 again, 2 times 5. 21 is 3 times 7. What we do is we think of this as almost like one big giant fraction. And just we start canceling anything that's the same on top and bottom. Because technically if a 3 is up here and a 3 is down here, won't those two cancel? Technically it's a 1, right? 3 divided by 3 is a 1. 2 divided by 2 is a 1. So whatever's left on top, multiply with whatever's left on the bottom, and we're good to go. We get the same answer. We're good? Again, pre-algebra, that's something you should say, Mr. Right? Okay, let's go for it here. So hopefully you know how to factor, something we've been practicing in Chapter 5. Factoring is going to be important. Again, Chapter 6, we factor. Chapter 7, we factor. Chapter 8, we still should have been factoring, or should factor as well. Once you get to Math 63, cover factoring in one single section, and we keep on going in Chapter 1. So we assume, Math 63, it's assumed you know how to factor. And you keep on going. Okay, anyways, let's go for it. X plus 5, that does not factor at all. Keep it. X minus 4, keep it. That does not factor at all. But how about x squared minus 16? Perfect. Difference of two squares. X plus 4, x minus 4. Okay, x squared minus 25. X plus 5, x minus 5. Perfect. Now we can just cancel anything that's the same top and bottom here. So I got myself, let's see, x minus 4 is gone with this one. And I personally like to leave little ones there, because then I know I factored it, and then I know what it sort of reduced down to. X plus 5 right here, yep, x plus 5, done. And then on top, since I'm only left with a single polynomial, I'm just left with a single term here. No need to put parentheses here. It won't be wrong if you did, and that's okay. So real quick, out of curiosity, show of hands, how many still kept their parenthesis there? Cool, okay. Okay, next one. Of course, they're going to get a little bit more challenging. So I think it's the factoring that's the challenging, and not so much the crossing off things that are the same, top and bottom here. So again, all yours. Try this yourself here. See if you can finish it up before I do. All right, let me start. About half of you guys are done here, so I'm going to start putting things together. Look up if you think you got it here. So this is a divide one instead of multiplication one, but I think we know from pre-algebra, what do we do? Change the divide sign into a multiplication symbol, and then we flip or take the reciprocal of the fraction in the back first. Then from here, now we start factoring. So if you factored first, that's okay, just flip that second one around. Alright, so let's see, 4 on the outside, x minus 7. Two numbers multiplied to -6, but if you add them together, it gives you a -1.
2 and 3.
2 and 3, which one's the negative? Perfect. So I got a -3 and a +2. Alright, on this one, difference of two squares, right? That one you should be very familiar. That's probably the easiest the forms that we studied here. A plus 2, a minus 2. Okay, two numbers multiply +21 add to -10. Awesome. -7 and -3. At that point now, we're just going to cancel things that are the same top and bottom. A minus 7s are gone. A plus 2s, gone. And the A minus 3s can't be. Remember, look at that. The A minus 3s they're both on the bottom. You can't cancel them if they're both on the bottom. Okay, so in this case, as I multiply things out, I have to have parentheses here, because notice I have a 4, and it still has a multiplication with the a minus 2, so in this case 4 times a minus 2. On the bottom, perfect, a minus 3 and another a minus 3. You can write it like this, that's perfectly fine, or if you really want to impress me, you can actually write it as a minus 3 squared. You're saying that there's two of the same exact terms there. Okay, question, raise your hand if you got that before I gave the answer. 1, 2, 3, 4, 5. Okay. Okay, and again, the difficulty is the factoring in these. Just seeing a few people still catching up here. Go for it. Question usually comes up though is, Mr. H, do we have to multiply the 4 back into this? Should we do 4 times a, 4 times, should we multiply this out? A minus 3 times another a minus 3, and depending on the math book, some math books do require you to multiply this back out, so you're going to FOIL it. The problems become very, very, very long when you do that, especially if you have like 3 of them. So let's say you had a minus 3, and then also an a minus 6. Now you're going to be doing FOIL 1, 2, 3 times. So in that case, that's the question there. The real question for mathematicians is, should this be sort of like the simplest form, or should the multiplication of everything be the simplest form, right? Because remember, you can't really just leave things as 3 times 4. Right? You have to multiply together to give you a 12. So that's where the debate goes on among the mathematicians is, do I multiply them out or do I not? Usually in conferences, we just arm wrestle to figure out who's going to get it, and then we just work it from there. Okay, let's go for it. Number 3. Again, give you a minute, try it yourself. Alright, so let's start. Let's start looking at these here. First I'll look at anything that needs to be factored. The 4z plus y does not need to factor down. If you have a monomial taken to a certain power, you don't need to factor that at all. This does not. This is the only one that needs to be factored. So let's rewrite everything here. 4z plus y. I got y to the third. I got a y over here. And again, looking at this here, the choice is between a 4z times 1z or a 2z times 2z. I'm going to choose the 4z and the 1z because of the little 4z over here. Yeah. And I figure if anything, it's going to reduce. So for your guess and check method, oh yeah, 4z times the z on this side. And then you got to think about, okay, what's going to give me a y squared? A y and a y, right? Perfect with that. Okay, so we've got a few little things here to consider. First of all, the 4z plus y, that's the easy one. That's gone, right? Like terms. Okay, with this y to the third and the y, got to consider the exponents here. So this one technically is a y to the 1. This is a y to the 3. So when you cancel these out, you're still going to have, that becomes a 1, but you're still going to have a y squared on the bottom. You've only got rid of one of the exponents down here. Okay, does that make sense? Because that sometimes is a whole stumbling block here. We're good? So if this one on top was actually y squared, we would cancel off the y squared, cancel off the y cubed, and leave us just an extra y. Right? It's sort of the difference between your exponents. That's what you want to keep. And you want to go to the one that has the greater amount of exponents. You keep that because that still has a few extra leftover y's there. All right, on top, notice also nothing left. Yep, so you still have those 1s. 1 times 1, you still have to have a 1. On top of fractions, if you cancel everything out, you still need to have a 1. On the bottom, y squared times z plus y is good. Okay, now let's move on a little bit more, even more tougher than this. So it's a division problem here. So before you do anything else, again, change that division into multiplication first, and then have at it here. Again, give you guys a minute, try it yourself. Alright, I'm going to start here since see about a little over half of you guys are done here. So again, first of all, let's switch the second fraction around here. The x squared becomes on top, and then you have numerator becomes the denominator here. So let's start factoring down. Two numbers, multiply to 2, add to 3.
So
2 and 1, or 1 and 2, depending which way you want to write it. Notice over here there's only 2 terms. Again. Okay, so let's try this again. Ah, no, we went back to the wrong slide. Chapter 6 is just weird for me here. Okay, so let's go for it here. So again, keeping everything else the same, the second fraction is the only thing that changes because the numerator goes to the denominator and the denominator goes to the numerator. Now we start factoring here. So 2 numbers multiply to 2 add to 3, 2 and 1, or 1 and 2, depending which way you write it. On the bottom here, there's only 2 terms here, so they do have an x in common. So let's factor out the x, leaves us with x plus 3, and that's good there. On the top, you have x squared, and the tough one here now to do. So, what did you factor out as the greatest common factor?
2s.
Perfect. You need the 2. You also need the x, because x is in every single term. Factoring that out, then left you with x squared plus 3x plus 4, and 2. Then the question is, can this be factored down some more? Because I still see an x. Yep. You guys are shaking your head. Yes. You can if you like. Just going to write it underneath right here. That's fine. I'm going to just rewrite the whole thing just real quickly here. So x plus 1, x plus 2 on the bottom. And 2 numbers multiply to 2 add to 3. And you should notice a little something extra as well. Notice this little x squared plus 3x plus 2 on the bottom here. Isn't that really the same thing that was on top over here already? Or on top of the original numerator of our first fraction. So that means x plus 1, x plus 2, both of those are going to cancel themselves out. Alright, now we're left with x over here and the x squared. So again, that becomes a full 1. This becomes an extra little x on top. Final answer. Oh no, not. Maybe not. Look at this. There's x here. There's x down here still. So cancel that one out, cancel that one out. Again, everything else on top is reduced, so we still have a little 1 here. What's left over?
X plus 3.
Yeah, times 2, is that right? So it's x plus 3 times a little 2 there. Okay, quick raise of hands. How many got that? Same answer as I did. Ooh, okay, a few little things here. Anybody can tell me any of the hang-ups that you guys experienced here on this one? What was the hang-ups?
Didn't factor it out completely.
Okay. Left it right like this?
Yeah.
Okay. Then go to the extra step on factoring. Okay. Anybody not see the x over here and the x over here? Okay, if you didn't do that, then you would have left with an x over here, right? Then you have a 2x, and you still keep on going. So then you say, okay, can I reduce any more? Yeah, I can still reduce the x's. So not just because you've put them all together, that doesn't stop you from still reducing some more if you see still like factors here. Okay, number 5. Let's jump back to multiplication. The only little issue here is the first term is not a fraction. Good? Alright, so what do? We just put a little 1 right there. That's all. We make it into a fraction ourselves. With that 1 being there, now we just do what we normally would do with the fractions. Alright, again, give you guys a minute here to finish it off. Alright, I'm going to keep on going here. So on top, how about x plus 6x minus 6? Bottom is left that 1 there. And the other fraction does not factor at all because there's nothing to factor here. But we do have some cancellation here that happens. Okay, now let's talk about this here. First, on top, I have two different polynomials, right? So they both need parentheses around them. Because we're going to multiply. If you don't put the parentheses around the x plus 2, that means the only x is going to multiply that x plus 6, and that's not right. On the bottom, notice there's just 1s. So remember with fractions here, if you just have a 1 on the bottom, that means you have a whole piece. It's all one piece. So you don't need to put a 1 here. This is just the answer right there. Alright, and number 6. A little bit same setup as number 5 here. Only thing I'm going to do, I'm going to put a big old humongous 1 underneath all those terms and let you guys finish. Alright, some of you are done already here, so let me set up mine over here. So c times c minus 1 times c minus 3 over 1, and then the c minus 1 on top still stays here, but c3 minus 9c, we can factor out a c here, and again leftovers would be a c squared minus 9, and again I think you know how to factor that one down some more. That's a pretty easy one there. Alright, again you can sort of write it underneath. I personally like to rewrite the whole thing. Just makes a little, for me, it looks a little cleaner here. Alright, at that point now we start canceling stuff. So that little c on top, little c on the bottom, it's that little monomial. C minus 3, c minus 3, and again don't cancel off the c minus 1s because they're both on top. They're not both one on top, one on bottom here, so let's keep those. Alright, the sophisticated way of writing it, c minus 1 squared, and then c plus 3. Again, I can drop the parentheses because that's the only polynomial that's there. Alright, again, here, show of hands, how many got that one before I gave the answer? Okay. Alright, let's change gears just a little bit here. The book goes into a little bit of an application section. It's called unit analysis. Something that we do a lot in chemistry. Something where you want to actually just change your units somehow, or you have it in one set of units and you want to somehow convert it to another. And that's what this is for. So unit analysis is a way to convert between measurements of units or units of measurement by multiplying technically by 1. And so we've got to understand this first. If you say 35,000 feet and you want to convert feet into miles, what we've got to do is we've got to multiply by 1. Isn't this whole thing really just a 1? Because 1 mile is actually 5,280 feet. So if I change this feet into a mile, it would be 1 mile over 1 mile. If I change this into feet, it would be 5,280 feet. So technically these two mean the same thing. They're just in different units. But how do I want it? If the feet is on top here, I want to put the feet down here so that the feet will cancel each other out. So in a sense, you're sort of not canceling the factors, you're canceling units out to get to the unit that you want. Again, it's going to look kind of weird. This is called dimensional analysis in chemistry. So you may have to use a little calculator here. If you have a calculator with you, may have to compute a few things here. So let's do 2 problems here. So there, suppose the Mall of America covers 93 acres of land. If 1 square mile is equivalent to 640 acres, how many square miles really does the Mall of America cover? And kind of nice, it says round to the nearest hundredth of a mile. Alright, I'm going to start it as well here. So first things first, we're working with this right here, 93 acres of land. An acre of land, let's go with 93 acres, and we're going to write it over 1 because there's no fraction here, so 93 acres. And acreage is a unit value that actually measures square. So like a square size here, just like area. Okay, in that case, here's what we got to do. I got to multiply by something called 1 so that at the end I'm going to have myself just only in terms of square miles. And it says 1 square mile is the same thing as 640 acres. Now I want this acres on the bottom of my fraction because I want to cancel out with these acres over here. So I'm going to multiply by 1 square mile is the same thing as 640 acres. Therefore, I'm going to put the acres on the bottom, assuring myself that these two will cancel. And then and the square miles is what I want, so I'm going to put those on top. The abbreviation for miles is MI. Kind of careful, if you just put M by itself, you're just saying meters, and that's not good. So So you can either write down MILE if you like, or just MI for the abbreviation. So the 640 goes on the bottom, the 1 goes on top. Perfect. The acres are canceled because we're trying to cancel you off units. And now exactly where we're on top, I got 93 times 1, or 93. On the bottom, 1 times 640 is 640. And now the only unit left really is square miles. Okay, and here's where the calculator comes a little handy here. 93 divided by 640 is approximately 0.15. If on the homework, if you're off just a little bit here, you know, you put 0.14, that's going to be okay for the paper pencil homework. Okay, so square miles, you could put SQ dot MI dot, or what you can do is you can put MI dot with a little 2, and that, again, because of the little square, remember, the exponent of 2 means squared. So now you're saying miles squared, which means the same thing. Since it says round to the nearest hundredth, this number would be the answer. Depending what you would, depending how you want to write the units, that's fine, but 0.15 would be the final answer. Okay, let's try another one here, and see if you guys can try this yourself here. So the forest chairlift at the North Star Ski Resort in Lake Tahoe is 5,603 feet long. If a ride on the lift takes 8 minutes, what is the average speed of the lift in miles per hour? So round the answer to the nearest whole number this time. So I'll let you guys try it yourself first. Okay, so I'm going to start it as well here. I guess we should talk about the typo here. So if a ride on the, should not say life, let's go if the ride on the lift takes 8 minutes. I guess you have to have life in order to ride on the lift. I don't know. Okay, so 5,603 feet long. We're gonna, and then it says if the ride takes 8 minutes to do so. Okay, good there. So this is how long the ride was. This is how long time it took. Now this is in feet per minute, and that's what we don't want. We actually want this in terms of miles per hour. How fast is this going by the normal average way we think about speed here? So hopefully did this here. So first things first, it doesn't matter if you try to convert the minutes to hours first, or you're trying to convert the feet into miles. It doesn't matter which way you go, just as long as we start converting things here. So let me do feet to miles. We saw that in an example problem here. How many feet are in a mile?
5,280.
Perfect, okay, cool. All right, maybe even a little better way to sort of illustrate this here. Let's do this here. At the end, what I want is miles per hour. That's what I want at the end, as far as units are concerned, maybe. Sort of thinking about that. Miles per hour. Alright, so I'm going to place my next fraction here. So I want feet on the bottom, because that's what I'm going to cancel. The unit that I want on top is miles. And then I figure out the numbers that make that happen. So 5,280 feet is the equivalent of 1 mile. That's cool, because now I am in miles per minute. Okay, now what I want, so I got rid of the feet. Cool, there it is, just in terms of miles now. Now I need to go from minutes to hours. This is probably an easier sort of example here. Question is, from where did I get 5,280? From the textbook here. I guess it's the equivalent of how many feet are in a mile. You may have to sort of look things up. I mean, you can even put, if you're sort of stuck on something like that, you can even Google it and just say how many feet are in a mile. But that's the ratio. That's the ratio. Just like the same thing is, we would think of, okay, how many minutes are in an hour? It's sort of the same thing, the same concept here. That's knowledge of it here. So, minutes, we want to put on top or bottom? I want to put the minutes, just the unit values. We want to put the minutes on top because we want to cancel those from the ones that are on the bottom here. So minutes go on top, hours go on the bottom, and now we think of the numbers that will make sense. 60 minutes for every hour that we have. And voila, awesome. Minutes are gone, love it. So now I got just perfect. I have in terms of miles over hour. So now what we do is we multiply all the tops together. 5,603 times 60 would give you 336,180 miles. And 8 times 5,280 gives you 42,240 hours. So then take that, divide those out, and you get yourselves, hey, look at that. Love it. So you can put miles on top, hours on the bottom, or even the abbreviation, because we use it so customarily, we just put MPH, which really just means miles per hour. I think you've seen that before somewhere. Okay. Again, kind of going slow through this here just so we get the concepts here. All right, let's keep on going here. Jumping to 6.3. I like the first two examples here because it sort of gives you a good illustration of what to do. And these are the easy ones. This is the ones that you already have common denominators. The tough ones, the long problems with a whole bunch of steps in them, those are going to be the ones that hopefully we don't get lost along the way, but those are going to be the long problems. I would say probably the longest problems in the textbook, just because there's so many steps. Time to get it. Okay, anyways. So just like pre-algebra, 5 over x plus 3 over x, do we have common denominators? Absolutely. So we're going to keep that common denominator. And with fractions, whenever we add or subtract fractions here, we only work with the numerators. That little plus sign really belongs to the 5 and the 3. So 5 plus 3 is 8. Cool. And at that point, look to see if I can reduce anything here. Nope. And I'm done. So yeah, there's an extra little reducing step here, still here. Just trying to say, okay, can I reduce anything? All right, do we need to see a pre-algebra sort of worked out example, or are we okay with this one? I think we're okay. Okay, so x over x squared minus 9 plus 3 over x squared minus 9. Do we have common denominators? Absolutely. Common denominator is x squared minus 9. And then what we do is we just add the numerators. X plus 3. They are not like terms, so therefore we're going to write them separately. Then at that point, then we got to think about, can I somehow factor, are there any common factors? And yes, there are. X squared minus 9 factors down, and then the x plus 3's cancel, then we're left with that as our final answer. Alright, so let's go for it here. Number 1 and number 2. All yours very similar to example 1 and example 2. Give you a little bit of time to try it yourself. Alright, so let's go with it. Number 1, the easy one here. So common denominator is y. That's great. Keep it. 9 plus 5 is 14. Can I reduce 14 and the y? I don't think so. The bottom. Since we have common denominators, no need to factor anything yet. Okay, don't start factoring here. So leave it as f squared minus 25. And on top, there's a subtraction now. So f subtract nothing is still going to be an f. And nothing subtract 5 is going to be a minus 5. And at that point, then you say, hey, you know what? Now can I, does anything factor, does anything reduce? Yes. The denominator does factor down into f plus 5, f minus 5, and then the cancellation takes place. And how about a 1 over f plus 5? Good there. Alright, so now the tough ones here. Those are the easy ones. Tougher one's number 3. Let's actually go back to pre-algebra. Let's just sort of understand this whole concept of what we do and when we do this. So 1/2 plus 1/3. Let's take a look at that. And then we'll slowly put in the variables into here. Okay, so looking at this one here, pre-algebra. What do you guys say? What's the common denominator? 6. It's what? 2 and 3 multiplied together, right? And that sometimes works out, sometimes not. So we both said 6. Okay, that's cool. So then we do is we go back and just say ourselves, okay, what would be a multiplier here to this 2 to give me a 6? 3, of course. So then I'm going to take this 3 also and multiply it times the top. We good there? Is everybody okay with the 3 on top there? Then we go over here to this one. Yep, 3 is here on the bottom. What do I multiply 3 to give you a 6? That's be a 2. So whatever I multiply on the bottom, I got to multiply on top. So 2 times 1 is 2. And we get ourselves a 5, 6. Good there? Let's add in the variable now. What is the common denominator between a y and a 3? 3y, of course. I need the 3 and I also need the y because they are not the same term. Then we go back. What should we multiply y to give you a 3y? 3. Therefore we multiply the top by 3. And again, if you want to show the sort of the steps here, you can kind of do this here if you like. Just so you can kind of see it later if you need to. But 3 times 2 is 6. Good there. And then we do the same exact thing for the second fraction. What do you multiply 3 to give you 3y? It's going to be a y. Therefore multiply the top by y, and we got ourselves a 2y. Alright, let's see if we can go some more here. Let's see, common denominator, now we have them. Yep, that's perfect, that's 3y now. That's good, 3y is good. Over here, 6 minus 2y. Hey, these guys are not like terms. So 6 minus nothing is 6, and nothing subtract 2y is a minus 2y. And now the only question is, does this reduce? Does it factor? Does anything factor here? The top actually does factor, huh? The top, you can factor out a 2 on top, left with 3 minus y, and again over 3y. Alright, now we've got to have a conversation here. If you have something that factors but it does not cancel anything, then again, this little question is, what's the simplest form? Is this the simplest form where there's really no operation to do? Or is this the simplest form where you have everything broken up into smaller pieces? So, mathematicians, we arm wrestle. And some people say this, some people say this. And then it depends who's writing the textbook at this point. Your book, I believe sometimes it leaves it like this, sometimes it leaves it like this. It just kind of just depends. My preference is that you get to this point here, because that shows me that you tried to see if anything's still reduced. Cool. And then you can always check for this answer somewhere in the back of the book, but then you have both answers to sort of compare. Okay, now let's get to the fun one here, number 5. Alright, let's begin the process here. Let's do this one together. And if you want, you can try number 6 by yourself. Alright, so looking at this here, we've got ourselves a little problem already here. Notice on the denominator, this is 3t minus 21. This is t minus 3. We have to factor first. We've got to get into its prime numbers here. So factor out of 3 leaves us with t minus 7. The other fraction does not factor out at all, so leaves us with t minus 7. Good there? So it's prime pieces. Okay, now what's the common denominator? I need the 3, and I also need the 3 minus 7. I need both of these, this one and this one. So then common denominator would be 3 times t minus 7, and another 3 times t minus 7. Alright, notice the first fraction, the denominators are exactly the same, right? So therefore there's no multiplier at all. Notice the second fraction, is there some kind of multiplier here now? Yeah, 3 here. Technically if we want to be the same, we would have to put a little 3 right here. And if we're putting a 3 right here, then we have to also put a 3 on top. So 3 times 2t makes 6t. Alright, now we're ready to put it together. We have common denominators, perfect, 3 times t minus 7. And on top, 1 plus 6t. So, you know what? They don't go together. I can keep it like that. Let me just do it like this here. Or, some students just like to prefer to write the variable in front as opposed to in the back. So 6t plus 1 also works. These guys are just exactly the same. No changes there. Alright, if you think you got it, number 6 is all yours here. Try it yourself first, and I'll work it together. Alright, let's go for it here. Those that started without me, go for it. Those are waiting for me. Let's do it together here. So first things first, like on the last problem here, I gotta factor this down. Do its prime little factors here. X squared minus 4 is x plus 2x minus 2. Alright, and with that said, now we have to get a common denominator. So, yep, I need x plus 2. I also need x plus x minus 2. And when I do that, I already have the x minus 2 in there, so no need to add further factors in. So notice this comes from my first fraction. And then when I start looking at my second fraction, the x minus 2 is already there, so no need to add anything else. So I keep it as x plus 2x minus 2. Alright, multipliers now. First fraction is exactly the same, no need to multiply anything, it's a 1. Second fraction, yes, there's x minus 2. The multiplier then would be x plus 2. And let's multiply the top by the same exact multiplier. But notice what we're doing here. X plus 2 divided by x plus 2. Isn't this technically just a 1? That's what we want to do. We want to be able to multiply by 1 because 1 times anything is itself that same number, right? That's kind of what we're doing. Okay, so x times x is x squared, x times 2 is 2x. And now let's put it all together here. The common denominator stays, and on top I have an x squared, and I like to do that. I like to start with the highest power on the x's first, to kind of just work our way down. The 2x is next, and the 1 is at the end. Alright, if you got to this step, you are doing great, but we got to ask ourselves, can I factor? And if I do factor, does anything reduce? If you do it in your head, that's fine. But you do have to check whether you can factor and reduce. So how about two numbers? Multiply to 1, add to 2. Hey, 1 and 1, that's right. And once you do 1 and 1 in your head, you know whether they're going to cancel off with this, right? So you can choose to keep it, leave it just like this, and that's fine by me. You can choose to show the factored form and say, Mr. H, look at that, there's the factored form and nothing reduces, so I'm good to go. So either this one or this one, they both are absolutely correct. Just which way you want to keep it. Alright, show of hands, how many got that one correct? 2, 3, okay. Alright, number 7. Okay. Again, let you guys try it yourself for here first. My hint is you have to factor both denominators this time. Factor both denominators and then form your common denominator from there. Alright, I'm going to start it as well here. Those waiting for me. So first fraction here, I got two numbers multiplied to 2, add to 3. How about 2 and a 1, is that right? Y plus 2, y plus 1. Alright, that's the factored form, that's awesome. Y squared minus 1. Y plus 1, y minus 1, perfect. Perfect, let's go for it. All we're going to do is you're going to take each of those terms and just bring it down. A y plus 2, I'm going to bring down to my common denominator. A y minus 2, let's bring this one down to my common denominator. So I got my first fraction already set. Look at my second fraction, y plus 1, I already have it. I don't need to write it over again. So then the other newest term would be the y minus 1. There's my common denominator. Alright, and then if it's a common denominator, it better be in both denominators here. So y plus 2, y plus 1, y minus 1. Okay, again, so many steps here. So now let's go back and look at multipliers. So what do I have to multiply the first fraction to get my common denominator? Yeah, I don't think so. Y minus 1, right? Because I have the y plus 2, I have the y plus 1, but I'm missing here the y minus 1. Alright, you can write it down at the bottom, or you can just do this. You can just write it on top. Y minus 1 will be a little bit easier to sort of think through. So y times y is y squared, y times negative 1 is minus y. Perfect. Okay. Cool. Air conditioning came on. Finally going to become cool today. Oh, never mind. Just went off. Okay, second fraction. Y plus 1, y minus 1. What's the missing one? Y plus 2. Let's multiply that on top. And again, you could put it down on the bottom. Y plus 2 is over here. That would be mathematically correct. The shortcut way is just to multiply the numerator only. So y plus 2 is good. Putting it all together here, still the common denominator, y plus 2, y plus 1, y minus 1. But on top, let's see, we're adding. That's a good thing here. So y squared plus nothing is still y squared. Minus y plus y. So let's go for it. Hold on. So negative y. So I'm going to just adding like terms together. Yeah, I added the y squared. Y squared plus, there's no y squared here. So it's really y squared plus nothing on this side. Gives you y squared. For the y's, it's negative y plus y. Those two will cancel. Cool. And then it's nothing plus 2. So there's your 2. Good there? So you're always only putting together like terms. Alright, y squared plus 2, does that factor? Yeah, y squared minus 2, does that even factor? No, that wouldn't even factor. Y squared minus 2, because that 2 is not a perfect square. Right. So yeah, keep it just like that. We are good with that one.
Can you just go over one more time how you got the top?
Oh sure, yeah, absolutely. The question is, can I go over one more time how I got the top numerator?
Yep.
Yep, sure. Alright, you guys okay with with the whole concept of how we got the common denominator though?
Yes.
Common denominator part was okay. So now we go to here. So y plus 2 is already here. Y plus 1 is already here. So there's one missing. And if I was going to fill it in, we'd have to have an extra in order for, let me get this little tablet started here. Okay, and let me put a different color on here just so we have a different color. Okay, so y plus 2, y plus 2, y plus 1, y plus 1. That's cool. I need a y minus 1 extra right here. So I could write it here, that would be fine. Just write y minus 1. That'll be fine. But the important part is that you multiply the top by that y minus 1. So now just notice this fraction is the same as this fraction now. Nothing missing anymore. But on top, I will have a y squared minus y. Is that good? Alright, the second fraction, put on this one here. So again, I want to make these exactly the same. That's the whole point here. So y plus 1, y minus 1 is already here, and here the new piece is the y plus 2. So I'm going to multiply y plus 2, boom, and I'm going to multiply this side by y plus 2. So now notice all these guys are the same with all these factors here. So I got the same factors or common factors, and that's good. Common denominator. So y plus 2 times 1 is the same thing. At that point now you get to put it all together. Okay, good there. Just to sort of walk through again. Cool. Alright. Next one, all yours again to start. Try by yourself here. Careful in the factoring on this one. In fact, maybe for this one I'll give you I'll give you actually a shortcut on this here. For our purposes, just factor the denominator first. Factor the denominator and stop there. We'll see a quick little shortcut here. Alright, let's go. So factored form of your denominator should be 3 on the outside, x plus 3 for the first fraction, and how about an x plus 3x minus 3? Okay, and this one is just to show you a little something here. Before you start putting all together and put a 3, the x plus 3, the x minus 3, sometimes you want to just check, because now you have a factored form here. So on this fraction right here, you may want to check, hey, now can I reduce something? Was there something that I could not reduce here because it was all compiled together? Now that I factored it into its prime numbers, hey, that 3 and that 3 are gone. So sometimes during the process, especially now that you got everything in factored form, you can reduce the fraction before moving on. Okay. Is it wrong? So Mr. H, will you get the wrong answer if you don't do that? No, you still will get the right answer. You'll just have to be reducing more all the way at the end. And you got to work with more numbers. Okay, so now we got rid of those 3's here. Now the question is, what's my common denominator? Yeah, I need the x plus 3. I also need the x minus 3. I need both of those. So x plus 3, and then the x minus 3. That's what I need. And then do I need to multiply anything with my first fraction? Need to multiply the x plus 3 with x minus 3. That will make the same thing. Therefore I go to multiply on top. And I got x times x is x squared. And x times the minus 3 is a negative 3x. Do I need to multiply anything with my second fraction? No, it's already that common denominator. That's cool. So 18 over there. Alright, so then keep my common denominator, x plus 3, x minus 3. Alright, on top, x squared minus nothing would be x squared. Negative 3x minus nothing is negative 3x. Or at least no like terms. And nothing subtract 18 would make a minus 18. Question, does that reduce?
Yes.
It does, that's right, okay. Let's see, something about 6 and 3, is that right? What signs for which one? Negative, I think it's negative and a positive, right? The only way you can get a negative 18. Alright, let's see, two numbers multiplied by negative 18, add to negative 3, that means the 6 has to be the minus, 6 has to be the negative. So how about x plus 3 and x minus 6? And does anything cancel? Absolutely, the x plus 3's are gone. Alright, I don't need any parentheses because I'm left with a single polynomial on top called x minus 6. No need parentheses on the bottom because I'm left with a single polynomial called x minus 3. Okay, good there? And of course the word problem here. Alright, write an expression for the sum of 3 times a number and the reciprocal of twice the number, and then simplify. Okay. Alright, so let's guess, since we're talking about numbers here, I'm going to just say this, let x be a number. That's fine by me. Some kind of number, any kind of number. So write an expression for the sum. I know I'm going to be adding here, but I got to get everything in terms of this variable. I'm adding 3 times a number. Hey, 3 times a number. That's going to be just 3x, isn't it? That's called 3 times a number. Okay, and the toughy one here, the reciprocal of twice the number. How do you write the reciprocal of twice the number? As a fraction. The reciprocal just means we're gonna put a 1 on top and put whatever that is, twice the number on the bottom. So 1 over 2x. There it is. That means the reciprocal of twice the number. Okay, so write an expression for the sum of 3 times the number and the reciprocal of twice the number. Hey, that's easy. I'm going to write a plus sign, and all I'm adding the 3x on one side and the 1 over 2x on the other. That's about it. Alright, question is, what's my common denominator? Hey, it's 2x. Of course it's 2x. You could put a little 1 underneath the 3x if you like, just to make it a fraction as well, but the common denominator is 2x. Alright, so that means, let's see, the first fraction gets multiplied by what? 2x. Awesome. 2x on top, 2x on the bottom. How about 2x to the 6th? The second fraction gets multiplied by what? Cool. Nothing, or you could use 1. Technically, how you want to look at it, that's about it. Because we already have that common denominator for that one. So on top, we leave a 1. No changing the numerator this time. And now we're going to put it together. So 2x, and we got 6x squared plus 1. At this point, can you factor the 6x squared plus 1 somehow? Into? Oof, don't think so. No, can't do that because 6 is not a perfect square. If it was 36, maybe. Right, because 6 itself is not a perfect square, so you can't break it down. Okay, let's